Hi everyone. Today we're going to talk about some material from the past two lectures. So we'll talk about judgment, decision making, thinking, and reasoning. So specifically today we'll go over the differences between System 1 and System 2 processing, and then we'll talk about various heuristics, so the availability and representativeness heuristics. And then we'll talk about some biases in judgment and how our judgments might be biased given certain information. And then we'll move on to the decision making. So we'll look at prospect versus utility theories, and then talk about deductive versus inductive reasoning and what the differences there might be. Okay, so first let's talk about judgment and decision making. So in general, we talk about these two different systems, or this two-system view we have when making judgments or decisions. So we want to say System 1 rapidly generates intuitive answers, which can then be monitored or evaluated by System 2. Although System 2 might be rare, and in some instances we depend solely on our System 1 processing. So System 1 might be intuitive, automatic, and immediate. So we'll get into this in a little bit further detail, but most heuristics are produced by this system. Then you have System 2, which is more analytical or more controlled. It's consciously monitored. It seems to be more cognitively demanding, for example, and we make little to no use of this system. We generally rely on our System 1 processing. So System 1 you can think of as coming up with this sort of gut estimate, and then in some cases we might use System 2 to determine whether this gut estimate might be good or might be bad. Okay, so we said heuristics are generally produced by System 1 processing, but what actually are heuristics? Well, they're a rule of thumb or a mental shortcut often based on our past experience. So they seem that they save us time and energy. They aren't guaranteed to be correct, and in often cases they'll lead our judgments astray. And they seem to be reliant on System 1 processing, so this fast, less controlled way of processing. Various types of heuristics that we rely on in daily life. So the first we'll talk about is the availability heuristic. So this is the idea that things that come to mind more easily we think are more frequent. So the judge probability of an event, how likely an event is to occur, is related to how easily it can be brought to mind. You can think of it as how fluent that event seems. So you can see this illustrated in the following example. You can ask participants which of the following events is more likely. So death by all kinds of accidents or death by strokes. Most people would say death by all kinds of accidents like motor car accidents, etc. But in reality, it's death by strokes is more likely. Same with death by suicide or death by homicide. Most people are likely to say death by homicide is more frequent, but in reality, death by suicide is. The same pattern is shown with death by cancer or death by heart disease. People are more likely to say death by cancer. And finally, death by shark or death by falling coconuts. And you can probably figure out what the correct answer here is with this one. So the idea with all of these different examples is that it's probably easier for you to think about hearing about deaths from strokes, or deaths from accidents, or homicide deaths, or sad cancer stories on the news perhaps. Because you can think of these more readily than thinking of someone who died of a stroke or died of heart disease, for example, you think they happen more often. So the ease with which you can think of these things, you can think of examples of homicide that you've seen on the news perhaps, you think that's more frequent than death by suicide because you hear about those less often. So even though these other things are happening more often, you just don't hear about them as often, and that influences your judgment of how likely those events are. So for example, you may read about lots of people or a few people going out and winning the lottery in your local newspaper. And then you go out and buy a ticket because you think it's more common than it actually is. Just because you've heard it in the news recently, you think that winning the lottery might be more frequent because you've read a few stories of people winning, for example. So in this way, our judgments of how likely an event is and the decisions we make, maybe going out and buying that lottery ticket, may be influenced by the availability heuristic in this way. So we can also look at empirical evidence for the availability heuristic. So in this study, people were asked to come up with examples where they were assertive in certain situations in their lives. And half of the subjects they asked to recall 6 examples, and the other half they asked to recall 12 examples. They were also asked some more general questions, including how assertive they thought they were. And what they found was that the people who were asked to come up with 6 examples actually rated themselves as more assertive than if they come up with 12 examples. So the idea here is that because participants in the 12 example condition struggled to come up with 12 examples of themselves being assertive, they thought to themselves, oh, well, since it's hard for me to think of 12 examples, I must not be that assertive. Whereas the people who came up with 6 examples might have had an easier time actually filling out all 6 examples, and thus rated themselves as more assertive overall. This also relates to various fluency effects that we see. The idea with fluency effects is that the easier we find it to acquire information, the more positively we rate that information, and the better we think we'll remember it. And that's shown in that study by Danny Oppenheimer, where more pronounceable stocks end up doing better, more readable essays are rated as better essays. So these fluency effects might also come into play here as well. Another example of a heuristic we may rely on is this representativeness heuristic. So for example, if you read the paragraph, Steve is very shy and withdrawn, invariably helpful, but with little interest in people or in the world of reality. A meek and tidy soul, he has need for order and structure and a passion for detail. And then participants might be asked, is Steve more likely to be a salesperson or a librarian? What most participants say is Steve is more likely to be a librarian. But in fact, Steve is actually 83 times more likely to be a salesman than a librarian, just because there are more salesmen in the U.S. than there are librarians. And so what we find with this heuristic is that people judge probabilities based on the degree that the situation is similar to or representative of their stereotypes or knowledge about that person. So characteristics might be representative of a certain kind of person. In this case, Steve has been described in how you might think of a librarian. But we seem to neglect these base rates, these prior probabilities, the fact that there are more salesmen than librarians when we're making these kinds of judgments. And they seem to do this even when there's other information that a rational person would use to make the best possible decision. So this brings up the idea of base rate neglect, so the tendency to ignore the prior probability of an event. And that's just what I mentioned earlier, that there are more salesmen than there are librarians, and we tend to ignore this information when making these kinds of judgments. Instead, we go with this sort of gut instinct. Well, he has these characteristics that are more similar to a librarian than a salesperson, so we'll judge them in the librarian category, even though it's actually much less likely for him to be a librarian than it is to be a salesperson, based on the number of people in each of those categories. A similar example of the representative heuristic is the following. So participants might read this paragraph. Linda is 31 years old. She's single, outspoken, and very bright. She majored in philosophy. As a student, she was deeply consumed with issues of discrimination and social justice and participated in anti-nuclear demonstrations. So then participants were asked to rate the following statements on a scale from 1, most likely, to 7, least likely. So Linda works in a bookstore and takes yoga classes. Linda is a bank teller. Linda is a member of the League of Women Voters. Linda is an insurance salesperson. Linda is a bank teller who's active in the feminist movement. And really interesting differences emerge here. So we'll go over those on the next slide. So what the researchers found was that participants tend to give higher estimates to Linda is a bank teller who's active in the feminist movement than they did for just Linda is a bank teller. Why might they have done this? Well, the description represents one person's stereotype of a feminist, perhaps, in the early 80s. And while they're relating these characteristics to someone who's a feminist, people are judging these basic probability principles. So the idea that Linda is a feminist who's also a bank teller, that probability can't be greater than just the overall probability that Linda is a bank teller, because all the feminist bank tellers are within that category of bank tellers. So two events in combination cannot be more likely than just one of its constituent events. So this is the idea of the conjunction fallacy. So people seem to be ignoring these basic probability principles when making these kinds of judgments. So there are also various biases that influence our judgments. For example, confirmation bias is a tendency to be more responsive to evidence that confirms one's beliefs and less responsive to evidence that challenges one's beliefs. So, for example, you might think from childhood experience, for example, that all big dogs are vicious. Because you think this, you might notice more examples that fit this pattern more readily. So you might have biased attention towards events where big dogs are vicious. And then you might recall more examples that fit that pattern more readily. So you might have biased memory for those kinds of events. So there's these various things, like it sure doesn't feel this planet is warming. You might think of, on a hot day in the summer, oh, how could there possibly be global warming? Or the Apollo moon landings were a conspiracy because you're focusing on that evidence that might seem somewhat sketchy, but not focusing on all the evidence that proves that there was this real event that happened. There's also this idea of illusory covariation. So this is the idea that we add causality to things that are not causational. So you think that one causes the other, but really they just vary together, and you don't know the direction of the causality. So we went over this example in lecture of this study done by this physician epidemiologist, where he found that on average, those who won Oscars lived 3.9 years longer than those who were never nominated at all. And he followed that up with Oscar-winning directors living 2 years longer. And it seems like these results are important because it supports theories that success may lead to social status, success and social status may lead to longevity in life. But another researcher said, well, that's not actually what's going on here. In fact, it's just those who live longer have more time to win an Oscar. So in this case, you think that winning an Oscar causes longer life, but you really don't know the direction of the causality. It could be that living longer causes you to win an Oscar just because you have more time to win that Oscar. So it's these two things that are co-varying together, that are varying together, but don't have any sort of may not have any sort of causality between them, and you impose that causality. So another phenomenon that we rely on that may bias our judgments in various situations is this idea of anchoring and adjustment. So it looks at how people make numerical estimations. So it seems like we typically start by anchoring on some salient number. Perhaps that number is provided to us in a question, and then we adjust that number from that initial number that was provided to us. So for example, if I ask you what percentage of the countries in the UN are in Africa, and we spin a random roulette wheel and it lands on 10, we get this median estimate of 25. But if the roulette wheel spins and lands on something larger, like 65, the median estimate tends to be larger as well. True answer is 53 in this case. So the idea here is that even though this roulette wheel is spun and the result of that roulette wheel spin is completely arbitrary, it still seems like people are biasing or are biased by that number and make their adjustments based on that initial number that comes up. In a similar experiment, if you ask subjects to estimate this mathematical equation, the average guess is low, 512. But if you reverse the order of it, the average guess is higher, around 2,250. But the correct answer is much larger than either of these. So it seems like people are doing the first sort of 1 times 2 times 3 times 4, and then sort of run out of time. So their judgment is lower because they're anchoring it on that number that comes up from those first couple of numbers they multiply. That causes the average guess to be higher in that second equation. So it seems like we're starting at this initial number that's provided to us and sort of adjusting a little bit from there. And that seems to be biasing our judgments. So now we're going to switch gears a little bit. We just talked about the different heuristics that we rely on when making judgments, and the different biases that might influence our judgments. And now we'll talk about the actual decision making. So given these kinds of judgments that we're making, how do we make a decision based on those? So the main goal of decision making is to get the most or the best stuff as often as possible. And in order to do this, it relies on two different kinds of information. So how important to you is each outcome, which we define as the utility, and how likely is each outcome, which we define as the probability. So according to this first theory, we'll talk about utility theory. A rational person should try to calculate the expected utility, sometimes called the expected value, of each option, and then choose the option that maximizes this. So utility theory is a theory about how we make decisions regarding money in this example. So we define expected value as the probability of a particular outcome times the value of that particular outcome. And for example, if you're playing roulette, you have a 1 in 20 chance of winning $100. The expected value would be that 1 in 20 chance times the 100, $5. So we can show this in various situations in the lab. So for example, would you prefer a certain $50 or a 50 chance of winning $100 or nothing? Both options have the same expected value, $50. In the first option, it's 100% times the 50, and then 50% times the 100. Each expected value is $50, but it seems like people are being influenced not only by this expected utility. Both of these options have the same expected utility or expected value, but it seems like most people choose the certain $50. And what this shows us is that we have these sort of subjective factors that are also playing in. So people are risk averse when it comes to gains. They want to make sure that they get the money when it comes to gains. Don't want to take a chance. Don't want to take that risk. So utility seems like possibly it can explain the subjective nature of decision making. Okay, so a different theory of decision making is prospect theory. And in prospect theory, it tries to model these real life choices rather than the optimal decisions as in utility theory. So this theory is trying to be more psychologically correct and take into account more of these psychological factors that might influence decision making, other than just the expected likelihood of the outcome and the value of the outcome. So the idea with prospect theory is that there's a bigger impact of losses than of gains, and that would take into account our tendency to be risk averse for losses and risk seeking for gains. So we're more loss averse. People are more likely to try and win that $50 and have that be a sure thing. But when it comes to losing $0 or $100, they're more willing to take the chance there. So what you can see is prospect theory modeled on these graphs below. And what you can see is if you compare winning $100 to losing $100 on that right graph, for example, the psychological value of losing $100 seems to be greater than the psychological value of winning $100. The psychological value of losing $100 is more negative than the psychological value of winning $100 is positive. So that takes into account here this loss averse tendency of decision making. And what's also interesting is that as you move further away from the y-axis, either in the negative direction or the positive direction on the x-axis, so the total dollar amount, the differences between dollar amounts becomes less and less. So what I mean by that is if you look at the difference between winning $0 and winning $10, there's a great increase in psychological value there. Winning $10 feels a lot better than winning $0. But if you look at that same difference, so a $10 difference, much farther down the x-axis, so comparing winning $1,000 to winning $1,010, the psychological difference is much smaller. So what that means in terms of the graph is the curve sort of shallows off as you get greater and greater on the x-axis going in the positive direction. Those differences, those $10 differences, if I ask you whether you'd want $1 million versus $1 million and $10, there's little psychological difference between those two effects, those two values. So this theory tries to take into account these the more psychological impacts of decision making, whereas utility theory is really just looking at the expected value and the likelihood of the outcome to determine decision making. This tries to model sort of more real life choices, why we're seeing these risk averse decision makings for gains, or for losses rather, and risk seeking decision making for gains. And this seems to account for that a little bit better than utility theory. So there are also some factors that affect how people make decisions, and one of these may be framing effects. So the idea with framing effects is that people tend to interpret a choice in terms of the given frame of reference. So if you think back to when we were talking about potential gains or potential losses, people seem to be risk averse when we frame things in terms of potential gains. They don't want to take that chance to win the $100 if there's a sure chance they can win the $50. And people tend to be risk-seeking when when decisions are framed in terms of potential losses. They'll take that risk of possibly losing 100 for the chance of losing 0, as opposed to the sure chance of losing $50. You can also think back to the trolley problem discussed in lecture. So for most people would switch the track to kill one and save 5, but wouldn't push someone off the bridge to kill one and save 5, even though the same number of people will be saved and the same number of people will be killed. By using these words, saved or versus die, it makes people choose differently. It creates different effects on decision making. So framing a probability of chance or scenario seems to... Okay, so now let's move on to talk about some of the thinking and reasoning material covered in lecture. Okay, so we discussed this difference between two types of reasoning broadly: deductive reasoning versus inductive reasoning. So deductive reasoning is going from one or more statements to a logical, certain conclusion, so that it's guaranteed to be correct, your conclusion. And inductive reasoning is going from many specific examples to some general statement, and this is not guaranteed to be correct. So your probable guesses are made up on the basis of prior evidence, so perhaps all the examples you've seen, and you jump to some conclusion that's not guaranteed to be correct or not. So we can look at how we use logic to make deductions in certain circumstances. So we can look at this in the context of a syllogism. So a syllogism consists of two premises followed by a conclusion, and we have to determine whether the conclusion is valid given the premises. So, for example, we might say all P are M and all S are M, therefore all S are P, and we can reason through this, and it doesn't seem like it's sort of this automatic, intuitive process that we're going through. It's hard to determine whether this statement is true or not, but if we put it in more concrete terms, so all plumbers are mortal, all serial killers are mortal, therefore all serial killers are plumbers, we can clearly see that this syllogism is incorrect. The conclusion is not valid given these premises. So you can see just a depiction of how that may be, these two different situations. So clearly not all serial killers are plumbers. You can have this situation where you have both plumbers and serial killers as part of this mortal group, but there may not be any overlap between the two. So the main point of this is that it seems like this deductive reasoning, at least in the case of syllogisms, is hard when things are not framed in concrete terms. If we're using these letters, it's not this automatic, intuitive process. We have to put some effort in terms of trying to figure out whether that conclusion is valid given the premises or not. This brings up an issue between the difference between truth and validity. So there's a difference between the conclusion of a syllogism being valid given the premises and it being true in the real world. So truth, we want to say, depends on the relationship between the assertion and the actual world. So for example, the statement snow is white is true of the real world. But Genna, our professor, being 6 feet tall is not true. The validity then depends on the relationship between the form of the argument and the conclusion. It's a sort of formal property, not what's true in the real world, but if you're given these premises, is the conclusion true or valid given those premises? So for example, you can take this syllogism, all dogs are animals, some animals are pets, some dogs are pets. We seem to be able to say that that is a correct or a true thing of the real world. Some dogs are pets. We know that to be true. But given the premises, that doesn't have to be true. That's not the logical, valid conclusion. This is easy to see if you switch out the word, given dogs, if you switch it to sharks. So all sharks are animals, some animals are pets, some sharks are pets. Now that that's not true of the real world, we can go back and see that that doesn't flow logically from those premises. So here it seems like it's since it's a true of the real world, you think that the logic is true or the logic is valid. Here it's not so. You can tell that this logic is invalid. So what this gets at is this idea of belief bias. So this is the tendency to accept an invalid conclusion if they're believable. That's what's going on in that blue box. And we seem to reject a valid conclusion if they're not believable. So you can see in that graph up there the difference between these two conditions. So in the left-hand bars, you're less likely to say, or if an invalid conclusion is unbelievable, you're less likely to endorse it as true. But if a valid conclusion is unbelievable, you're not as likely to say that conclusion is true as if it's a believable conclusion. So this is the idea of belief bias. We accept invalid conclusions if they're believable. That's what's happening in that blue box there. Although it may not be always valid given the premises. Look at these conditional statements to examine deduction. So a conditional statement has the format if X, then Y. So the first part is the antecedent X, the second part is the consequent Y. So if the first part provides a condition, under which the second part, the consequent, is guaranteed to be true. So we have various different formats of these, of which you don't need to have memorized. These are just for illustration purposes. So the modus ponens, for example, is if P, then Q. So if it rains, then Nancy gets wet. So if P, it rains, then Q must follow, Nancy gets wet. Arguments of this form are valid. So they're valid given the premises or the antecedent. The consequent is valid given the antecedent. We also have the affirmation of the consequent. So if P, then Q, you get Q, Nancy gets wet. Does that mean that has P happened? So you would say therefore P. But arguments of this form is invalid. So Nancy could have gotten wet for a different reason other than it raining. So arguments of this form are invalid because if you have Q, it doesn't mean that P had to have happened. It could have been something else. So we also have these two other forms. So the modus tollens. So the premise is if it is raining, then Alicia gets wet. So if R, then W. Alicia does not get wet, not W. The conclusion then is it is not raining. And these are valid. This is a valid form or a valid argument given the premise. And then there's the denial of the antecedent. So if it's raining, then Alicia gets wet. If R, then W. It is not raining. Therefore, Alicia does not get wet. Again, this is an invalid argument. What you should be taking from this, though, is it doesn't seem like we do these processes in our daily lives. We can formally describe these processes using these fancy Latin terms, but intuitively, this doesn't seem like what we seem to be doing. It's hard for us to reason in this way. So the idea that it's hard to make these logical deductions given these premises is shown in this graph here. So what you find is that for the modus ponens and modus tollens, which are valid conclusions given the premises, people seem to, almost 100% for the modus ponens, although even though the modus tollens is also a valid conclusion, only around 50% of people are able to say it as such. And for the affirmation of the consequent and the denial of the antecedent, which are invalid conclusions, people are still endorsing them as valid in some contexts. So clearly this doesn't seem to be a very intuitive way of reasoning. People seem to be confused about these things. So how do we make deductions if not using these formal rules, if not going through this formal step-by-step process, examining an antecedent and determining whether the consequent has happened? That doesn't seem very intuitive. So there must be a different way in which we're making these deductions. So there are these different theories about how we make deductions in the real world. So the first one that we spoke about is our mental rules. So these are very language-like formal rules of logic. So the idea here is that we have this stock of mental inference rules that apply in a fixed order to the premises of an argument. So we have these sort of internal natural deduction rules, and people mentally check these rules in a fixed order until they find one that's relevant to the premise. So, for example, you might have a rule for the modus ponens, and it's easy. So if something occurs, then something else has to occur. And that seems like it's easy in that case to see that the modus ponens is valid. But for something like the modus tollens that doesn't have a rule, a mental rule, it's more difficult. If something doesn't occur, then the thing that caused it has to have occurred. It seems to be a very confusing way of phrasing things. And mental rules would say, okay, well, we don't have a rule for the modus tollens, so it's hard, but we do have a rule for the modus ponens, so it's easy. So maybe that's accounting for some of the confusion with how we're making deductions in the real world. And then we have this idea of mental models. The mental models say we have something more pictorial. We have some model of what the world would be and see if it makes sense given what's going on. So deductive reasoning involves these diagrammatic rather than language-like representations. So these representations are employed to evaluate the validity of arguments. So we can see how this plays out in an empirical task. In the context of the Wason 4-card selection task. So the main idea with the task is that each card is a number on one side and a letter on the other side. And the participants are asked to turn 2 cards to test a proposed rule. So the proposed rule might be something like, if there's a G on one side of the card, then there's a 3 on the other side. So you have to flip 2 of these cards to determine whether this rule is correct or incorrect. And most people tend to flip over a varying amount of cards. So people might say, okay, you have to flip the G and the 3, or the G and the P, or the 3 and the P. But actually you have to turn over the G to make sure there's no 3 behind it. Otherwise a 3 would violate the rule. And you also have to turn over the 7 to make sure there's no G behind it. It seems like it's hard for people to realize this, though. People tend to flip over a variety of different cards. It doesn't seem to be intuitive for people to perform this task. But we seem able to reframe the problem to make it easier for people to solve. So we have another proposed rule. In this case, if someone drinks beer, then he or she must be over 21. And each card has an age on one side and a drink on the other. So now it's easy for us to see, okay, we have to check the person drinking beer to make sure they're over 21. That would be the first card. And we have to flip over the last card, the 19, to make sure they're not drinking beer. So make sure there's a different drink on the other side. We don't really care about the 2 cards in the middle because the person drinking Diet Coke could be over 21 or under 21, and the person who's 23 could be drinking any drink. And the same rules actually apply to the cards on the previous task, but it's harder for us to reason about them in these sort of abstract terms. So this brings up the idea of these pragmatic reasoning schemas. So the idea here is that a pragmatic reasoning schema is a general but non-abstract rule that relates to a particular kind of goal. And these seem to be learned through experience and possibly through social interaction. And they allow for people to make specific inferences about expected outcomes that reflect social dynamic involved in specific situations. So it seems to be this sort of generalized set of context-sensitive rules. So you can see here that 61% of college students got the Wason card sorting task right when the task was framed in these sort of real-world terms, versus only 19% when it's framed in these sort of abstract terms. And the idea here is they're using some sort of pragmatic reasoning schema of what it means to be over 21 and how that relates to what drink someone can drink in order to solve this kind of task. So this seems to be somewhere in between the sort of syntactic, content-free rules of inference, as mental rules theory would state, versus sort of memory of specific experience. It's this generalized set of these context-specific or context-sensitive rules. Okay, so let's finish up talking about inductive reasoning. We were just speaking about deductive reasoning. So inductive reasoning is the idea that in many cases we can't rely upon deductive inferences. Instead, we rely upon this idea of induction. So this is going from specific examples to a generalized conclusion. And importantly, induction does not guarantee a correct answer, and some inferences are more likely to be right than other inferences. So for example, we would like to form universal generalizations about the world. All x's are y. So we want to say that all swans are white, for example. And these might be based upon prior experience. So swan, if you see one swan that's white, you see another swan that's white. You can see your 3,000th swan that's white, and you might conclude that all swans are white. However, what's important to note here is that even one counterexample can make your induction wrong. So if one day you go out and you see a black swan, then your induction, that conclusion based on all this prior experience, that all swans are white, will be proven wrong given just this one counterexample. Okay, so that's all the information we have for you guys today. I just wanted to remind you again that course evaluations are now open. If we would really appreciate if you go in and fill out your course evaluation, both for Professor Ehrlichman and for your TA. They're really important for improving ourselves as teachers and making better experiences for students down the line. So we'd appreciate if you take a couple minutes and just fill out those course evaluations when you get the chance. Thanks everyone. Have a nice rest of your week.